that you guys probably don't like. Law of sines is an easier formula to remember. The law of sines problems tend to be harder. Law of cosines is a more difficult formula to remember, but the problems tend to be easier. Okay? So, in this section, you guys will learn how to solve. By S and A, we're talking about sides and angles. So a side angle angle or an angle side angle triangle, and how to solve side side angle triangles. And then we're going to do one word problem with these at the end. All right, so definition. If none of the angles of a triangle is a right angle, we call the triangle oblique. An oblique triangle will either have 3 acute angles or 2 acute angles and 1 obtuse angle. Obtuse, remember, means an angle that's larger than 90 but smaller than 180. So this is the first case if all 3 angles are acute. Second case if 2 of the angles are acute, and then we just have 1 large angle. So pretty straightforward. All right, so how do we solve this? All right, solving an oblique triangle means still find all the sides, find all the angles. Okay, here's your warning. This is how to get a big sad face on your test. Warning, you cannot use the methods from 4.1 to solve an oblique triangle. So you cannot do a squared plus b squared equals c squared because there is no right angle in these triangles. That's why you need a different formula to do these, okay? We have 4 different possibilities to consider. Case 1, you have 1 side and 2 angles. So either an angle side angle or a side angle angle triangle. Either case, you guys see how there's 2 A's and 1 S, okay? Case 2, you have 2 sides and the angle opposite of one of them known as SSA. Please write it in that order because if you write it backwards, please don't cuss at me. We're more classy than that, okay? You guys get my joke? Don't write it in a different order, please. This can result in either, highlight this, no triangle, 1 triangle, or 2 triangles. It is possible to solve these problems and no triangle exists, so there's no solution, which you guys will actually see in this section, okay? Cases 3 and 4. Case 3 and case 4, these we will talk about in section 4.3. These 2 we're going to talk about in section 4.2. So is everyone cool with that? These are the 4 possibilities I'm trying to show you guys, but cases 3 and 4, we actually can't use the law of sines to solve. We'll have to use the law of cosines, which you guys will learn most likely Friday. Hey, there it is. Cases 3 and 4. Huh. I'm so smart. Okay. All right. Next is, what is the law of sines? In any triangle with sides little a, little b, and little c, with angles big A, big B, and big C opposite of them, to solve for the missing sides and angles. This is the law of sines. Sine of A over little a is equal to the sine of B over little b, which is equal to the sine of C over little c. This is the law of sines. Now, how many fractions do you guys see? 3. In order to use this formula, you can use any of the 2 fractions. So you can say these 2 equal each other and solve what you're missing. These 2 are equal to each other and solve for what you're missing. Or you can say the first one is equal to the last one and solve for what you're missing. Does that make sense? Okay. So you only need to use 2 fractions at a time. And then what's cool about this is the reciprocals are also true. So that means that, and you guys will see this when we do the problems, sometimes it's easier to write it this way. Little a over sine A is equal to little b over sine B, which is equal to little c over sine C. So those of you guys that had Math 3 honors last year, I actually was hoping to get here at the end of the school year. We just ran out of time. So you guys got to see it in pre-cal. For the kids in Math 3 honors this year, I hope to actually make it this far to show them this. Because if they don't see this in this class, then they'll never see it ever. Okay. So let's do an example. Oh, it's supposed to be 40 degrees. Sorry, guys. 40 degrees. All right. Please don't be lazy, guys. Some students got not mad, but they would get annoyed with me last year because I'd ask them, please draw a picture. Because if you draw a picture, it helps you kind of visualize what you're missing and what you need. So is this going to be a right triangle? No. So I'm not going to dock you guys points if it's not a perfect triangle. I'm not going to break out my protractor and say, hey, that's not 40 degrees. But do you guys agree that I need a big A, big B, and big C? So that means that I have a little c across big C, a little b across big B, and a little a across angle A. Label what you know. So I know that this is 40 degrees. I know that this is 60 degrees. And they told me that this is 4. So I need to know what little c is, what little b is, and what big C is. So now, without even using the formula, what's something I could find? Big C, right? So this part hasn't changed. All the angles in a triangle still add up to 180. That didn't change. So it's going to be 180 minus 40 minus 60. So that gives me 80 degrees. All right. So here is my law of sines. Sine of A over little a is equal to the sine of B over little b, which is equal to the sine of C over little c. Okay, so let's say I want to solve for B next. So that means that I have to use this fraction to find little b. Does that make sense? What is the other fraction I must use? Why? Yeah. Don't we know what little a is? And don't we know what angle A is? Do I know what little c is yet? So I can't use this fraction if I don't know both parts. Does that make sense? I have to know both parts to use the fractions. So I know these two. I know what this is. I just need to solve for this, okay? So do you guys remember me telling you guys that sometimes it's easier to use the reciprocals? What are you solving for here? An angle or a side? A side. Whatever you're solving for, I would use the formula with what you need on top, because that'll make the math easier. So since I need a side, I'm going to use the reciprocal formulas. So to find little b, I'm going to say little a over sine of A is equal to little b over the sine of B. Now, before you guys plug in any numbers, hopefully this makes sense. How do I solve for little b? What would I multiply both sides by? Sine of b? If I'm solving for little b, I need to get rid of this, right? So can't I multiply both sides by sine of b? So that means that this will cancel. So then little b is equal to a times the sine of b divided by the sine of a. What was a? Little a. So 4 times the sine of, what was big B? 60 degrees divided by the sine of what? 40 degrees? You must have a calculator. So I would use alpha x. And when you guys do these, just to get you guys ready for your homework and your tests and stuff, can you guys round to 2 places? What do we get? You guys should get 5.39. Okay, does these steps make sense, guys? Questions? All right. What else do I need to find? Little c. So do you guys agree that I need to use this fraction? Okay. Try to make your lives easier Which one of these would be smarter to use, A or B? Think about your answers. A, because if I want to use this, that's when I would need to use that storing trick I showed you with your calculator, where you have to store that value and use it again, because you'd have to use the exact number in order to make sure your answer, when you round it's not off. So I need to find little c, so I'm going to use the reciprocals again. So to find little c divided by the sine of big C is equal to, I'm going to use this one because if I use B, I have ugly answers. So if I want little c by itself, I can multiply both sides by the sine of C. So then these cancel. So then little c is equal to, little a was 4 times the sine of 80 degrees divided by the sine of 40 degrees. Okay. I've been seeing some weird things the last couple weeks, and I just thought about this in case you guys do this. Is this 2? Please don't say, oh, 80 divided by 40, hey, that's just 2. No, don't do that. The angles, don't do that. Just literally just type this into your calculator, okay? Please don't invent math on me in the middle of a test. What do we get? 6.8 what? 13? Hooray. Okay. Questions? Can we handle this? This is a pretty easy formula to remember, but you guys won't see it today, obviously, because we have 4 minutes left. But when we get to examples 3, 4, and 5, things get really weird. But it's kind of cool. I'm excited to show you guys. All right. Let's just write down the directions for the next problem, and then we'll start here tomorrow after your test.